Hello students, welcome to ePhysics. Students, in this video we will be starting from the part where we left in the previous video. In the previous video we were discussing the last topic that we discussed was electric potential and electric potential difference. So there electric potential students is denoted by capital V, which is equals to, according to the definition, the work done upon charge. Okay. Now, students, this work done upon charge is equals to, if we find the unit, it is equals to, work done ka unit is joule divided by coulomb, which can be written as joule per coulomb. Okay. Now, students, because we know that this is a lengthy thing to write all the time, that is why we have considered a small unit, small term, that is volt. Okay, and it is denoted by capital V. Okay, students, now how will we define 1 volt? 1 volt. So 1 volt is defined when 1 joule of work is done to move 1 coulomb of charge from one point to another. Okay. Then we say that 1 volt of potential difference has been created across the conductor if 1 coulomb of charge is moved by doing, if 1 joule of work is done on it and it is moved, okay, and it is moved, then we say that the total, the potential difference created is equals to 1 volt. Okay. Now, what is Ohm's law? The next topic we have is Ohm's law. Students, Ohm's law says that the voltage across a conductor, that is V across a conductor, is directly proportional to the current, that is I. Now students, if we remove this proportionality sign, we have to put a constant over here multiplied by R. And students, this R is constant of proportionality. Okay, constant of proportionality, and this constant of proportionality is considered as resistance. Okay, we call it as resistance. Now students, this resistance is nothing other than a characteristic of any conductor which opposes the flow of current. Suppose this conductor has resistance R, then what will happen, that it will oppose the flow of current. Oppose the flow of current. It will not stop the flow of current, but it will oppose it. It will only oppose it. It is similar, you can understand it like we have a pipe in which one blockage has been created by any stone. Now the water entering into from this side will definitely come out of this side. The only difference of the water entering and water coming out is the water is entering into the pipe with a higher speed, and let us consider V1, and the water is coming out with a lower speed, let us consider V2. Here V1 is greater than V2. That is, the velocity of the water entering is greater than the velocity of water coming out of the pipe. Similarly, if we have a conductor and it has resistance R, then the amount of current entering will definitely come out. The only difference will be the amount of current entering the circuit or the conductor will be with a greater speed and coming out with a lower speed. Okay, because what has happened over here, students, the conductor has a resistance which is opposing the flow of the current. Okay. Now students, according to this law, that whenever there is a directly proportional things is happening, then the graph so formed. Let us consider this is a graph. This is x-axis, this is y-axis. The x-axis denoting the current and y-axis denoting the potential difference. Then we know, according to the Ohm's law, potential difference is directly proportional to the amount of current flowing through the conductor. It means more will be the potential difference, more will be the current. If we increase the potential difference, then again the current will increase. Again, if we increase the potential difference, the current will increase. So when we draw the graph over here, what do we see? We see that a straight line is formed. So this directly proportional proportional sign comes to play in this graph by showing that the potential difference across any conductor is directly proportional to the amount of current flowing through the circuit. Clear? Now students, how will we define 1 ohm? In the previous slide, we have studied that V is equals to I multiplied by R. Here, we can write R is equals to V upon I. Okay. Now students, 1 ohm of resistance can be defined when 1 volt of potential difference is created across any conductor and 1 ampere of current flows through it. Then we say that in that conductor 1 ohm of resistance have been created. Let us consider a conductor in which 1 ampere of current is flowing through it, and the potential difference across the conductor, let us consider it is 1 volt. Then here in this conductor the resistance has been created, and that resistance is equals to 1 ohm. What is ohm over here students? The ohm is nothing, this is denoted by OHM. Okay, ohm, this is the unit of resistance. Okay, unit of resistance. Clear? So this is how we defined 1 ohm. Now, what are the factors students in which the resistance of any conductor depends? So the first thing, that resistance is directly proportional to the length of the conductor. Okay. The second thing is it is also it is inversely proportional to the area of cross section. Okay, area of cross section of the wire. Cross section. More will be the area, less will be the resistance, less will be the area, more will be the resistance. It is also proportional to, this is first, this is second. This also depends on the nature of the material. Okay, we will discuss it. Nature of the material when we discuss the formula. Nature of material. Clear? And the next thing is the temperature. It depends on temperature. And it depends directly, of course. If we increase the temperature, the resistance increases. If we decrease the temperature, the resistance also decreases. You might have seen mobile phone students, whenever the temperature of your mobile phone increases, the phone used to lag. Okay? The phone lags, and phone lags because the temperature of the phone is increased. Okay? The phone is getting heated up. Clear? Now, how will we, find the value of it? We can find it like, so we can find it like, if we erase it, this part, let's erase this part. Okay? Now here it was length. Now according to these two equations, equation 1, let us consider this as equation 1, this equation 2. Resistance is directly proportional to length and inversely proportional to area. And when we remove this proportionality sign, we have to put a symbol, and that constant, we have to put a constant, and that constant, this is constant. Okay? And rest of the thing, rho L upon A. So this is the next formula of resistance that we have to study. Now, this constant here is known as resistivity. Resistivity. And how will we find the unit of this resistivity? From this formula, students, we can write rho is equals to, this is pronounced as rho. Okay, rho. Now, resistivity is equals to R multiplied by A divided by L. And we know the unit of resistance is ohm. The unit of area is meter square divided by meter. 1 meter gets cancelled. Therefore, the unit is equals to ohm meter. Clear? So, the unit of resistivity is nothing other than ohm meter, and resistivity is the nature of the material. It is just the nature of the material. Clear? This is the nature of the material. So we have discussed the third thing over here. First, it is directly proportional to length. Second, it is inversely proportional to the area of cross section. Third, it depends on the nature of the material. And fourth, that we have discussed, it depends on the temperature. More will be the temperature, more will be the resistance. Lesser the temperature, less will be the resistance. Clear? Now, system of resistance. Students, in system of resistance, we have two types. two systems actually when the resistance are connected one after another. Okay, one after another, then we say that the connection is series connection. And if the both the ends of the resistors are connected to one point only, then we say the connection is parallel. Clear? We will discuss one by one both these things. Now let's start with the series connection. Students, let us consider we have resistors. Let us consider three resistors only. Let us say R1, R2 and R3. Now here students, what happens? The amount of current entering into this circuit, let us consider that is I, will definitely come out from here. Okay? That is I, of course. Now students, the amount of current entering is I for this circuit, I for this also, and I for this resistor also. The only change is happening is that here the potential difference is something else, here the potential difference is something else, and also here the potential difference is something else. Let us consider the potential difference for R1 is V1, R2 is V2, and R3 is V3. And these three potential difference is created due to the source of the current. And let us consider that source of the current has the potential difference V. And this V is equals to V1 plus of V2 plus of V3. We know from Ohm's law that it is equals to R multiplied by I is equals to V. And let us consider the equivalent resistance of this whole circuit is equals to Rs. Okay, now it is equals to V1. So I amount of current is entering through this resistor having resistance R1 plus again for this second resistor I amount of current is entering and the resistance is R2 plus for this also I amount of current is entering and the resistance is R3. Okay, students, in all these three we have one thing in common, that is I Rs is equals to, this is I common, so we are left with R1 plus R2 plus R3, and similarly we can proceed further as well, but here we have taken three resistors only, that is I Rs is equals to, this I and I gets cancelled. Okay, so we can remove this I. So we are left with Rs is equals to R1 plus R2, okay, plus of R3. Clear? So this is the formula of the series resistors connected in series. Now let's move to the other part, that is resistors connected in parallel. Students, let us consider we have resistors connected like this. Okay. Now students, all these three resistors, let us consider R1, R2, R3 are connected from one end only. Okay. And the potential difference, because the end point of all the three resistors are same, and the potential difference, let us consider that is V for all. Okay. Now the current, let us consider I amount of current is flowing through it. So here the amount of current entering will be different, here it will be different, here it will be different. Let us consider for resistor R1 it is I1, for R2 it is I2, for R3 it is I3. So here students, the amount of current, that is I, was distributed into I1 plus I2 plus I3. Students, we know the formula that V is equals to IR from Ohm's law. Therefore, we can write I is equals to V upon R. Clear? And here, students, let us consider the overall resistance of this parallel circuit be RP. Okay? The overall resistance. Here, it can be written as V upon RP is equals to, again, potential difference for all the three resistors are same. Therefore, it is equals to V upon R1 plus V upon R2 plus V upon R3. Now, V upon Rp will be equal to, let us take V common in all, 1 upon R1 plus 1 upon R2 plus 1 upon R3 This V and V gets cancelled. Therefore, we are left with 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the equation to find the resistance of the resistors connected in parallel. So students, here we have the formula 1 upon Rp. This is not the equivalent resistance. If we reciprocal this, then we will find that it is equals to Rp. Then we have to solve this also. Then we will get the, equivalent resistance of the resistors connected in parallel. Suppose we have two resistors, that is 1 upon Rp will be equal to 1 upon R1 plus 1 upon R2. Okay. Now, this 1 upon Rp is equals to R1 multiplied by R2, that is, this becomes R2 plus R1. So this is not Rp, this is not equivalent resistance, this is 1 upon Rp. To find Rp, we have to reciprocal this one. So this becomes Rp is equals to R1 multiplied by R2 divided by R1 plus R2. Clear? So this is the final equation for resistors connected in parallel. Now here students, let us discuss one question. What would be the new resistance if the wire, let me choose one test. What will be the new resistance if length of the conductor is doubled and thickness is halved? Now students, let us consider, first make a table, initial and final. Now initially let the conductor's length is L and finally it becomes twice of L. Now student, when we talk about wire, the ends of the wire are in the shape of circle and the area of circle is pi r square. Initially let us consider the radius is r, and finally when it is halved, the radius will become r by 2. Therefore the area becomes pi r by 2 ka whole square, which can be written as pi r square upon 4. Okay. Now we know the formula r is equals to rho into L upon A. Let us consider this is equation 1, and for R1, and R2 will be equal to rho into twice of L because the length is doubled, this one, and the area initially it was A, that is pi r square, and finally it was pi r square by 4. Pi r square by 4. Students, this can be written as rho into L upon pi r square, this 2 let us write it separately, 2 multiplied by this 4 goes up over here, 4 here. Now students, we can write this rho L upon pi r square as from equation 1 equals to R1. So this is R1, 2 into 4 is equals to 8. So the new resistance is 8 times the initial resistance. Okay. Now, so that's it with the video students. Thank you very much.